AP Stat students, it's Mrs. Opal and
Anders
and
Annika.
And we're here today to talk about Unit 4 probability distributions. They're going to get back to their distant learning, okay? But they just wanted to say hi. Okay. All right, let's get cruising. So we have our basic probability distribution. Up here, I have just a simple one is the number of dogs in a home people own, okay? One thing you need to be able to do with this is just answer basic probability questions. For example, this one right here is where it says the probability that X is less than 3. You need to know that, hey, my X is less than 3 right here, and I can just add those probabilities up, okay? Hopefully that one should be a pretty simple one for you. One thing they might say, though, is find the mean of the distribution or the expected value of the distribution. This is on your formula sheet. You need to know exactly how to do this, okay? So let me show you that formula sheet right now. Right here is the expected value, okay, for that formula or for a probability distribution. And what you're doing is you're taking that first observation you see times the probability of that observation plus the second observation times the probability of that observation, and so on and so forth. Now, you can also do this in your calculator. So what you would do, okay, is you'd go to that graphing calculator and you'd hit Stat, Edit, you'd put your list in. Now, I'm just going to put an easy list in. And then you put your probabilities in, right? So 0.2, let's do 0.3 and 0.5, okay? And then what I'm going to do is I'm going to go to Stat. I'm going to arrow over to Calc, one variable statistic, L1, and then L2, and then calculate like that. And you'll notice if you've done it right, your SX will be missing. So this is the expected value, 2.3, and this is the standard deviation of that as well. Now, the big thing you need to know is please, 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 if you have a calculator like this, you need to go back in after you write it down and go back to that one variable stats and go ahead and delete that L2 right away or clear it out there, because that could mess up further things for you on the test. So just don't forget to do that, okay? So again, it was stat, arrow over to one variable stats, L1, L2. Now, if you have an older calculator, you would put one variable stats, L1, which is second 1, comma, L2, second 2, okay? Okay, I went through that fast, so rewind. If you need help with anything, make sure you can do that on your calculator. I always say become one with that calculator, right? So make sure you do know how to use that calculator, and we'll go from there. On that note, I should say, for those of you who don't own a graphing calculator, please, please, please be practicing using the MCA calculator. I need to check in how, I don't know if they're going to provide one. I don't know. We'll just have to, I'll figure that out. But be practicing this calculator online so you know how to use the calculator. Very, very important. Okay, let's move on here. So going back to our PDF. When we find that expected value, okay, like you said on that formula, right? You see that summation sign. So you're taking the first observation times the probability of that observation, and then you continue that. Now, I showed it to you in the calculator, but you do have to show your work on the AP exam. So you need to know how to use this formula. So going to our PDF right now, okay, I would say, okay, the mean, the expected value, I take that first observation right here, times the probability of that observation, plus the second observation right here, times that probability, plus the third times that probability on and so forth. Okay, let's move on to the standard deviation. That formula is also given to you, and I have that right here. Now, I shouldn't say that. The standard deviation is not given to you, but the variance is, and we know that the variance is the standard deviation squared. I feel like it's doubtful that they're going to put this one on the test because you need to use a computer. But if they do put this one on the test this year for the year 2020, right? I don't know, weird year for this test. If they do, I would encourage you to do it on a piece of paper, take a picture of your work and submit it that way. Okay, so how do I do that? Now, I must have found that expected value was 1.19 because I have the formula plugged in here to show you how. How do I find that standard deviation? reading through the formula, the sum of the observation minus the mean, which is that expected value, squared times the probability of that observation. Okay, so let's look. This first observation 0 minus the mean, which I found to be 1.19. Square it times the probability of that observation, which is 0.25. Then I do it again. 1 minus the mean. Why 1? Because 1 is our next observation. Okay, so then I square that times the probability of that observation. Well, the probability of that 1 is 0.47. And I continue, and so on and so forth. And you notice I did a dot, dot, dot there, and that is totally fine to do, okay? Now, here's the catch, you guys. You have to show your work, but again, if you go, you can just fill in what you got when you do that calculator. So in this case, I mean, it's not the right values, but you can at least see here. One variable stats, L1, L2, go down and calculate. And that standard deviation is right there, 0.781. You will be docked if you do not show your work. So make sure you guys know how to do that. Okay, let's move on, you guys, to the next thing. It's my PDF here, excuse me. Okay, moving on, talking about transformation. So what happens if I want to transform something? I don't know if you guys remember, but this is when we talked about El Dorado Community College. So we know the mean and we know the standard deviation. And then we went and we transformed. We said, okay, we know on average how many credits people take. And then now we know how much it costs for each credit. Plus then there was this additional cost for this activity fee, right? Okay, so without like going too much into it, let's just say we have this X distribution, which we do up here. And we want to transform it for whatever reason. And how we want to do that is we want to multiply everything by 10 and then add 2. You do not need to go and take every observation up here and multiply it by 10 and add 2. All you need to do is you need to take that mean, okay? So you would take the mean of 1.19, right? Because that's what I told you it was before. And you'd multiply it by 10 and add 2. The mean, the center goes through the entire transformation. But remember, standard deviation is only affected by multiplication, not by adding or subtracting, because standard deviation is about spread, right? And so when you multiply, that spread changes, but when you add or subtract, that just shifts it. It doesn't change the spread within. So you just take that standard deviation, which it looks like is, we got right here, I don't know if it's 8.1 or 4.1, doesn't really matter. Essentially, all you need to know is you take that standard deviation, you multiply it by 10, but you do not add 2. Okay, I'm going fast, so slow down, right? Slow down if you need help, or pause, rewind, write down questions if you want me to make a longer video about something. I'm more than willing to do that for you. Let's cruise over and let's talk about combining variables. So back to that El Dorado Community College, if you guys remember in class, if you can go back in your notes, those of you who had me first semester, okay? We then talked about, we said, okay, well, El Dorado Community College also has like a satellite campus, kind of similar to, I got my master's at St. Mary's, and the actual St. Mary's is in Winona. I didn't go to Winona to get my master's. They had a satellite campus in Minnetonka, so I went there, okay? And they talked about combining, you know, on average, how many credits do people take together? That was in class what we talked about. Or how much does it cost together? Things like that. So this is what this one's talking about in a different setting right now. I'll just quickly read through it. It says, let's investigate the result of adding and subtracting random variables. Let X equal the number of passengers on a randomly selected trip with Pete's Jeep Tours. Let Y equal the passengers of a randomly selected trip with Aaron's Adventures. Define X plus Y. What are the mean and the variance? Okay. So with that being said, they already gave us that expected number of passengers in the long run. So if you're interpreting, remember you're saying in the long run on Pete's Jeep Tours, we would expect an average of about 3.75 passengers on his tour. Okay. Standard deviation, that's the average distance observations are from the mean, okay? Big deal, that's gotta be memorized, written down in your notebook. You know exactly where to find it for this year, right? Because it's a different year. All right, so with that being said, if we wanted to figure out on average, how many do they have like together, right? Total, on average, you would just take Pete's trips and Aaron's trips and add them together to get 6.85. Okay, now the big thing with the standard deviation where people make mistakes, because sometimes you find the difference of it. So let's say you wanted to say on average, how many more does Pete have than Aaron on his trips? Then you would subtract. But whether you're adding or subtracting variables together, the standard deviation remains the same. There are two things you have to remember. You have to check. This was our first introduction to conditions. You have to state that the two variables are independent. So we did that there. Pete and Aaron's chores are independent of each other. Then you need to go on and you take their standard deviations, you square them, and you add them together. So however many things you are combining, you could be combining, Annika's tours and Anders' tours with Aaron and Pete. Then you would be taking 4 standard deviations, squaring them and adding them, right? But before that, you have to state that they're independent. So you square them, add them. If you just add them, that's the variance. You take the square root, that's your standard deviation. Okay, I'm done with this part. I'm going to go into combining variables with that z-score because that's a common one as well. If you have any questions about combining variables right now, what I just talked about though, take a second to pause and write it down. Let me know what I can do or how I can support you more. Okay, so moving on here. If I can move on, let's see, arrow over, there we go. I'll move this. Okay, combining variables with the normal distribution. Remember, whenever you see normal, think ZOMs. You're going to be finding a z-score, you're going to be going to the table, and you're going to be finding a probability, a p-value, okay? 1 second. All right, guys. So forgive me if I backtrack here for a second. My kid's pizza timer went off, so I paused the video. Where we're moving into right now is combining variables with that normal distribution. So as I've said many times, when you see the word normal, you can, I don't want to say automatically jump to, but you can assume that a z-score is most likely coming. ZOMs. Here I'm talking about Jenny and Johnny. Jenny gets 8 hours of sleep on average. Johnny gets 6 hours. That means on average together, they get 14 hours of sleep a night, right? It also gives their standard deviations as well. What's the probability they will get more than 18 hours of sleep? That means combined together that they come to school. How much did you get? Johnny got this much, Jenny got this much. What's the probability that it would be 18 or more together? Okay, ZOMs equals observation minus the mean divided by that standard deviation. So the observation is usually always in the question. What are we observing? What's happening? Okay, that would be that 18 right there. Minus then the mean. So on average, how much do they actually get together? So that's where we add those two values up. So that's that 14 right there. Divided by that standard deviation. That's where, okay, you need to make sure you take both the standard deviations squared, add them together, and take the square root, which you can see right here. Now, please, please, please don't forget when you do that, you have to state that their sleeping patterns are independent of each other. Now, the rubrics change every year. Sometimes when it states normal, AP does not expect you to say that it's normal. I have instructed you anytime you see normal, I would like somewhere on here saying normal distribution with a mean of 14 and a standard deviation of whatever that is, just to cover your basis, to make sure you're getting that full credit. So we get 1.79. This is a probability that's greater than, which means if I drew the curve, right, I'd have 14 right here with my standard deviation, 18, and I'd be shading to the right. So when I go to my table, then I just need to remember that I need to do 1 minus that p-value, and that's 0.0026. Deep breath, we're almost done. The last thing covered in this unit is the binomial probabilities versus the geometric probabilities. Okay, let's start with binomial probabilities. There are 4 things that make something a binomial probability. The acronym we learned was BINS, okay? B stands for binary. There's a success, there's a failure. I stands for independent. Each trial is independent of each other. N stands for the number of trials are fixed. And S means the probability of success is the same for each event, okay? So let's just quickly go through here. It says Mr. K is shooting a 3-point jump shot. Hold on, give me a second here. Oops, let's see, can I go up? Mr. K has a career shooting percentage of 80%. Mr. K is going to shoot 33 pointers during a practice season. So right there, that's your fixed number of trials. Now, on the formula sheet, so let me show you that right here. They do give you the binomial distribution. They talk about the mean, and they talk about that standard deviation. So you'll have that formula there if you need that, okay? So let's go up, move back. All right, so we would just take 30 times, I don't know why, you guys, this is a great question, and this is an error. It says 80% here, but 0.6 here. So let's go ahead right now, and let's actually assume that this should be 60%, because I see just looking through it continues to have 60%. That shouldn't mess us up too much, just a rewind, change it to 60%. Okay, with that being said, then we just take 30 times 0.6, and that gives us 18. And then that standard deviation, 30 times p, 0.6, times 1 minus p, 0.4. Take the square root, that's our standard deviation. Now, here's the fun part. Finding those probabilities. Okay. Now, find the probability that Mr. K makes exactly 20 of those 30 free throws he's making. Those are like a jumping for joy problem. If you see an exactly on the test, you should feel very happy. Straightforward. That's a binomial PDF. PDF is always when it's an exact. So the probability that x is equal to 20, I do want to see that probability statement, is equal to binom PDF 30, that's my n, p, that's my probability, and k, that's my 20. Okay, so binom PDF 30, n, p, and k. I'm going to pause it real quick because my husband got a phone call. I'll be back in a second. Okay, guys, so like I was saying, exactly is always a PDF. Make sure it is okay to show your work using calculator speak here, but you must put N under it, P under it, K under it. Now, if you're like, wait, how do I find that on my calculator? I can do this. MCA calculator. Forgive me. Okay, guys, so here's how you get there. You would go to second stat. I lied. Has it been that long? Oh my goodness. You go to second vars. Sorry, the buttons are so little there. And then I'm going to scroll up because it's a little bit faster to go that way. And I have the binom PDF right there. And that's my N right there, the number of trials. There's my P, and that's my K value that they say is the X value. And you go ahead and paste. So play around with it. Make sure that you can get this answer right here. And if you don't have the newer calculator, you just type it in as you see it, N, comma, P, comma, K. Okay, let's move on now. The probability that Mr. K makes at most 20, and just making sure that you know at most means less than. So at most is less than or equal to 20. And we've talked a lot about this in class, and refer to your notes as well. Whenever it's less than or equal to, that's what the calculator does. The calculator does not do less than. It does not do greater than. It does not do greater than or equal to. It only does less than or equal to. Okay, less than or equal to, excuse me, as a CDF. It does do equal to as a PDF. But anytime you have an inequality, whether it's greater than, less than, you need to somehow make it so it is a less than or equal to. Okay, in this case, that's nice. So it says, what's the probability they make at most 20? So the probability that X is less than or equal to 20. That's your binom CDF, N, P, K. And you do need to write that under there. Practice with your calculator. Make sure you know where to find it. Okay, what if, though, it said, find the probability that Mr. K makes less than 20? Well, your probability statement then would be the probability that X is less than or equal to 19, because less than 20, you need to rewrite it. So if you need, what I can do is I can just show you my going like this, right? So sometimes what I tell kids is I say, just list everything out. It could be 1, 2, 3, dot, 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 all the way to 19, 20. If it wants at most 20, it's 20. It would be then the probability that X is less than or equal to 20, right? That's great. But if it says the probability that it's less than 20, then that's the same as the probability that X is less than or equal to 19. So then what would your binom CDF look like? It would be binom CDF N. Okay, so N was 30, P, which was 0.6, K is now 19. And again, this is only if the question would have been phrased, what's the probability he makes less than 20, not at most 20. Okay, let's go back to that PDF and let's finish up here because it's a longer video today. The probability that Mr. K makes at least 20, okay? Whenever you see the word at least or it's a greater than type problem, again, I do think it's helpful to list it out like this, okay? He wants to make at least 20. So that means he wants to make 20, 21, 22, all the way up to 30. And you think about now when I'm doing a greater than or equal to, you want to think about what do I want and what do I not want. At least 20 is all of these numbers here. So I don't want all of these numbers. So I'm going to do 1 minus what I don't want. 1 minus the probability that X is less than or equal to 19. Because remember, everything's got to be phrased in less than or equal to work on the calculator. So that would be 1 minus binom CDF N 30, 0.6 for that probability, and K, which would be that 19 there. Okay, binom's done. We're going to move on to our last thing, the geometric. Geometric, what's the difference between binom and geometric? Geometric is wait time until your first success. Okay, so let's talk about this one. The population of overweight manatees is known to be 40%. You select a random manatee and weigh it. And then you repeat this selection until one is overweight. Find the probability that the fifth manatee you choose is overweight. Jumping for joy one, guys. This is an equal to one, an exact one, okay? So you can do this in your head or you can use your calculator, PDF, okay? I shouldn't say you can do it in your head, excuse me. You can do it by hand, all geometric ones, or the PDFs you can do by hand easily. Not a big deal. But if you want to use that calculator, it's a geometric PDF, and you do your P and then your K, and you do have to identify under that that's a P and that's a K. Type that in your calculator. You should get 0.05184. Where is that? It's the same location as that binomial, so hit second vars. Okay, where you're going to want to use your calculator, in my opinion, is when it is an inequality. So make sure you know how to do those greater than or less than, and I will give you some examples as well. But find the probability that it takes more than 5 attempts to find an overweight manatee. So that's the probability that X is greater than 5. So if I go back to my smart notes here, I always think it's always helpful to write out what it could be. It could be the first manatee, the second manatee, third, fourth, fifth, so on and so forth. Whenever it's a greater than, think about, right? Or really, to be honest, anything. Think about what do you want here. If it's a greater than, you have to do a 1 minus. So I believe the problem, excuse me. Oh, I can't get there. Yeah, it says greater than 5. So when I go to my, promise I can get there. I want greater than 5. So that's right here. Everything I want would be 6, 7, 8, so on and so forth, all the way over here. So then what I don't want is I don't want it to be right here. I'm going to then say that's going to be 1 minus the probability that X is less than or equal to 5. So same as binomial, with the calculator only works with less than or equal to, okay? So we have to rewrite things so it's less than or equal to, it's still equivalent, right? 1 minus the probability of X is less than or equal to 5. So what would I type in then? That would be 1 minus geometric CDF, the probability 0.4, comma 5. And you do have to write down, this is my P and this is my K. All right, the last thing, let me going back to my PDF. Okay. Just making sure you know how to find the average. How many would you expect to choose before you found one to be overweight? And that is 1 over P, and that has to be memorized, or in this case for the year 2020, written down on that notebook, since it will be an open notes test. Making sure you know exactly where it is, because you'll only have a certain amount of time. You can't be shuffling through those papers. All right, you guys, I made it. I'm sorry, it was lunchtime when I was making this, and my husband got a phone call, so there's a couple things that got broken up, so if I was repetitive, forgive me. If you have any questions, please let me know. Thank you guys, and have a wonderful day.